Yeah, so welcome to your summer finance course. Um, so I guess just to start out to convince you that what we're doing here is worthwhile. Gary put together a few examples of well of of situations where people who weren't knowledgeable at finance and like what can happen to them. So, for example, what if I told you that you could walk out of here and skip this class, but you could win the lottery? Um, and you basically the deal is you could win the lottery, but you wouldn't learn anything that I'm going to teach you here in this class. Um, what would what would you do if you were offered that option?
Um, I don't know. Probably walk out and win the
Yeah,
lottery.
I mean the obvious answer is I'll take the money, I'll take a couple $1 million, but um, estimates say that nearly one-third of lottery winners will become bankrupt. So you might not necessarily be that much better off. Um, Another example, what if I said you could walk out of the class and as long as you walk out of here and you don't learn anything in this class, then you would get to be a professional athlete, like professional, basketball player, softball player. Although the earnings for softball players aren't quite as great as they are in the NBA. Yeah, you'd be a professional golfer, make a couple $1 million a year.
Probably go out and be a professional. Whatever.
Right. So, nonetheless, if you look at the stats for basketball players, the average salary is like over $5 million a year, which I think is one of the highest in professional sports. It might be the highest. And yet, the NBA Players Association estimates that within 5 years of retiring, 60% of players go bankrupt. Um, and then the third example, you probably get the idea by now. But what if you could walk out of the class, but you get to be um, the heir to Bill Gates? Like he'll write you into his will and give you all his money when he dies. Again, most people would say they would take the money, but um, just one example from history is the Vanderbilt family. Um, they were basically so William Vanderbilt was a shipping and railroad tycoon. By the time he died, he had a fortune of like $100 million. Left it all to his son. Left it all to one of his sons. Um, his son, by the time of his death, had expanded the fortune to almost $200 million, and this is in 1885. And yet, in 1973, when 120 descendants gathered for the first family reunion, not a single one of them was a millionaire. And this is, $200 million in 1885 was worth its equivalent to like over $200 billion in today's money, which is, blows away Bill Gates' fortune. So, so the point that I mean, these are kind of in your face examples, but the point is that just being wealthy is not a guarantee of future wealth or the ability to retire even comfortably. Um, and we would argue that a basic knowledge of finance is virtually a guarantee of being able to retire with at least a comfortable retirement savings, and and it's more important than just coming into money in large sums at some point in your life. So with that, we'll move into the first the first topic, which basically we'll spend all day on this. Compound interest. Albert Einstein said that the most powerful force in the universe is compound interest. So, as you'll see, it's pretty amazing. So, just basically, we're just going to start with the basics and kind of build our way up. So, question to you is: if you had $100 today, you put in a savings account that earns 10%, how much money will you have in a year?
1,000.
So 10% of 100 would be $10.
Okay.
So you basically get $10 interest, and then you'd still have your $100 that you put into it, so you'd end up with $110. So the way you do it is you take 100 times 10%,
Okay.
and then you add back the 100 that you started with, end up with 110. And so so this is just hopefully this looks kind of intuitive the way this is written. But then we can rewrite this a little bit. If we factor out the 100, then you can kind of see that the first equation is equal to. You can kind of see that these two equations are equivalent. You factor out the 100, and you get an equation that's 100 times 1 plus 10%. And it's, again, equals your money at the end of a year, which is $110. So, you with me so far? Does this make sense? Okay. So, moving on, how about a year after that?
And so you just keep going in the same.
Yeah, so now you have $110. So you'd earn 10% on $110.
Okay.
Yeah, so
Okay.
here's basically how you
Okay. All right.
look at it. So you've got 110 at the beginning of the year, multiply it times 10%, which, as we said, is $11.
11. Okay.
And then you add back the 110 you started with.
Okay.
Um, so now this 110, that was what we had after 1 year,
Mm-hmm.
and so we can rewrite that. Oh, first of all, actually, sorry, got a step ahead of myself. We factor out the 110 again, right? So this basically is the same equation that we had before, except it's 110 instead of 100 that we're factoring out. But then this 110, this is what we had after year one, so we can rewrite it as this equation from year one. You remember this from year one?
Right.
So I guess with that, we'll move into our first Excel exercise, which is basically to build a spreadsheet that does all that math for you.
Okay.
And then you can rewrite the equation again, and just, these two multiplied times each other is the same as 10% plus 1 quantity squared.
Okay.
And if we basically want to look at what the numbers in this equation mean, the $100 is what we started with at the beginning, the very beginning. The 10%, that's our interest rate. And then raising it to the second power here, that's the number of years. So, and then that gives us the future value after 2 years.
Okay.
So this is just the same equation again. And then if we look at it generally, this is the principal. We'll signify that with P. And then we'll use R for the rate and T for the number of years. And that'll give us the future value. So this is the general formula. Basically, if you wanted to say, starting with $100, and I want to find out any number of years later, you can basically just use this formula and stick in the number of years for T, and it'll tell you how much money you would have at that time. So here is an example from history. According to tradition, in 1626, a Dutch colonist purchased the island of Manhattan from native people for trade goods valued at $24. So the question is, if they had taken the proceeds from the sale, the $24, and invested the money at 10%, how much money would their descendants have today? So before I even let you start working on the question, I'm gonna show you the answer. It's a really big number. It's more than millions. It's more than billions. It's more than trillions. it is 155 odd quadrillion dollars. Um, so this is kind of why Albert Einstein said the compound interest is the most powerful force in the universe. You start with $24 in 1626, and 374 years later, you end up with 155 quadrillion dollars. Um, and this is how we got there.
Okay.
We take the principal, which is $24. We're using the same interest rate as before, which is 10%. And then the number of years is 2008 minus 1626, which is, it's like 382 years, I think.
Now, for those of you who are watching this as a video, following along on your own, I'm going to walk through this Excel exercise with you. So the first thing we need to do is go to this website here and download the Excel exercise. So open an internet browser, and we're going to go to the following URL, weiner.andrew.j.googlepages.com/intro to finance. And you might want to bookmark this page because this is where pretty much all the Excel exercises, all the PowerPoint files from the class are located here. So for this exercise, if you go ahead and click on Excel Exercise 1, and you can just go ahead and open it with Excel, or you can download it. And once you've got it open, you'll see that there are actually two tabs on this spreadsheet. The first one is called Year by Year, and if you read the directions at the top here, what you're supposed to do is for each year from 1626 until the present, create a row that shows principal and annual interest. The second tab is called FV Formula, and what you're going to do here is just create a formula in one single cell which will calculate the future value of an investment in a given year. And the inputs are going to be your start date, your end date, your principal, and your interest rate. And the goal is for your formula to spit out the future value based on those inputs. So why don't you go ahead, starting with the year by year tab here, why don't you go ahead and take a shot at completing this Excel exercise, and you can just stop the recording and open the Excel spreadsheet, and then when you're done, hit play again, and I'm going to go through the Excel exercise, and I'm actually going to build it from scratch so that if you are having any problems, you can just watch how I do it, and hopefully everything will become clear. So I'm literally going to do this completely from scratch. So the goal here, remember, is to, for each year, have a row, and in that row we want to say how much principal we had in that year and how much interest was earned during that year. So the first thing I'm going to do is I'm going to create a column called year, and I'm also going to need a column called principal and a column called interest. Now my first year is 1626, and what I want to do is I want to have one row for every year. So what I'm going to do in this first column here is I'm just going to list all the years from 1626 through 2008. And rather than type them out, there's a fairly easy way to have Excel do this for you using a simple formula. Now all formulas start with the equal sign, so type equals and then click on the cell above, which is A5 plus 1, and Excel goes ahead and it calculates 1626 plus 1, and it comes up with the result 1627. And what you can do now is just copy this cell, and if you select a few cells below it and you right click and paste, it will just paste the formula, and each cell will just be one number higher than the cell above it. So in cell A7 here, the formula is A6 plus 1. So it's taking 1627, which is what's in cell A6, and it's adding 1, and the result is 1628. And likewise in the cell below it, formula is A7 plus 1, the result is 1629. By the way, if you highlight a cell and hit the F2 key, that will show you what the formula in that cell is, and it will also highlight any cells that are inputs in that formula. And so this is a handy way to check your formulas and see what it is exactly they're doing. So anyways, what I can go ahead and do is just copy this all the way down until I get to 2008. And now one way to copy is to right-click and select Copy, and then you can right-click and select Paste. A faster way to do it is to hit Control-C, and that's a shortcut for copy, and then we can just go ahead and select a whole bunch of cells. I think we're going to need 300 and some. And then to paste, the shortcut is Control-V. So Control-C as in cat for copy, and Control-V as in Victor to paste. And then, as you can see, Excel does all the calculations for us, and if we go all the way down to the bottom, oh, looks like I need 2 more rows here. So Control-C, Control-V, Control-V again. Now I've got all the years from 1626 through 2008. Cool. Now, the next thing is in year 1626, I'm going to just type in the amount of principal that I have, which is the amount of principal I started with, which we said was $24. And the other thing that we're going to need here is we're going to need to have our interest rate, which we said was 10%. And we're just going to have that sitting in this cell here. Oh, by the way, if your columns are ever too narrow to read the text, you can just double click here, and that will automatically resize the column so that it fits all the text in it. Now, in this cell, cell C5, I want to know how much interest I earned in 1626. And that is simply 10% times 24, which is $2.40. So what I'm going to type in here is, again, a formula starting with the equal sign, and then I'm going to say 24, which is my principal, times 10%, which is my interest rate. Hit enter, and I get $2.40. Now, a side note here, if we want Excel to display these numbers in dollars and cents, what we can do is highlight the cells and then hit Control, Shift, and the number 4. So you hold the Control key, hold the Shift key, and then tap the number 4. And that will reformat the cells in dollars and cents. Now, for 1627, we want to find out how much principal we had. Now, in the first year, we just typed in $24, which was, we know that's how much we started with. But in future years, we want Excel to calculate the principal using a formula. And the formula is simply going to be the prior year's principal plus the prior year's interest. And that will give us the current year's principal. So in this case, again, starting with an equal sign, it's going to be prior year's principal, which is 24, plus the prior year's interest, which is $2.40. And that gives us the principal for 1627, which is $26.40. Now, for the interest in year 1627, what I would like to do is to just copy down this formula that I used in the prior year. The problem is, as you're going to see, when I hit Control-C to copy and then Control-V to paste, I get 0. And the reason is that since I moved one cell lower, all the cell references in my formula also moved one cell lower. So here I was referencing B5 and F2, whereas here Excel automatically adjusted so it's now B6 and F3. What I would like to do is to have this be F2 as well. So what I can do is I can tell Excel not to change the cell reference for F2 when I copy down. And the way that you do that is with a $sign. In this case, I want a $sign in front of the row number 2, and that will tell the computer to freeze the cell reference at row 2. So as I copy down to the next row and the next row and the next row, the formula will always reference F2, and it will not move down its reference to F3, F4, F5, etc. So let's see what happens. I hit Control C, and I hit Control V, and you can see that my formula is still referencing F2 even though I moved the formula down one row. So now what I can do is I've got a formula here, which is just adding the principal and the interest from the prior year. I've got a formula here, which is just multiplying the principal from the current year times the interest rate. I can just copy both of these cells, and I can just select all the way down and paste. And as you can see, Excel does all the rest of the work for me. As long as I've written my formulas correctly, Excel will do the rest of the work. So for example, in year 1657 here, if I look at the formula, I hit the F2 key, the principal here is equal to the prior year's principal plus the prior year's interest. And the interest in this year is equal to this year's principal times F2, which is the 10% interest rate. You can go all the way down, and what you'll see is eventually the numbers get too big and they don't fit in the column. So what we can do, remember, is double click here, and that will make the column wide enough so that as the numbers get bigger and bigger, the column's wide enough that you can still read them. So let's scroll all the way down to the bottom, and we can see that in 2008 we end up with 155 some quadrillion dollars, which is exactly the amount that we came up with in the PowerPoint presentation. So very cool, we came up with the same answer. Now, before we move on to the second tab, there's just a few things that I want to mention here. One is we can make our spreadsheet look a little nicer by making all of these, making all the text centered. So the way to do that is to select all of this stuff and then click on this button, which will center the text. Another thing we can do to make it look nicer is to make this underlined and bold, since these are our column headings. I'll do the same thing with my interest rate label. Now the other thing I like to do with my spreadsheets, and I highly recommend that you do the same, is I like to distinguish between inputs and formulas. So for example, B5 here is an input. I typed in 24, that's just the amount we started with. Every cell below that is a formula. It's the result of adding the principal from the prior year and the interest from the prior year. So since this cell B5 is different than the rest of them, I like to color code it to distinguish it as an input. And you can do the same thing with 1626, your starting year. Now your starting interest is not an input, that's a formula. It's based on your starting principal and your interest rate. The only other input in the spreadsheet is the interest rate. And so now I know that all these things are formulas, and these guys in yellow here are inputs. So if I wanted to come back to this later and ask myself what would happen if I had started in the year 1726 instead of 1626, all I do is I change that yellow cell, and all the other cells, which are formulas, will automatically adjust accordingly. Likewise, I could change my starting principal amount to $30. And I could see, well, now I end up with a little bit more money at the end. And likewise, I could see what happens if my interest rate is 8.5%. 8.5% instead of 10%, and all these cells will adjust accordingly. Okay, so let's move on to the future value tab. And the goal here is to just write a formula in a single cell which will calculate the future value of an investment at a given time in the future. And the inputs that we're going to need are a start date, an end date, a principal amount, which is our initial investment, and an interest rate. Since these are inputs, I'm going to color code them yellow, just like I did before. And we'll use the same start date, 1626, end date 2008, principal $24. And again, if I want to reformat this, I do Control-Shift-4, which makes it turns it into dollars and cents. And then our interest rate is the final input, and that's 10%. Now this cell is where I'm going to type in my future value formula. And all this is we're going to go to that PowerPoint presentation, and we're going to use this formula right here. So principal times the rate plus 1 raised to the exponent of the number of years. So principal amount, and I can just arrow over. Principal amount is $24. I use the star symbol for multiplication, which is the star symbol is located just above the number 8. So you hit Shift 8 for multiplication. Open parenthesis, rate plus 1. And then for exponents, you use the caret symbol, which is located above the number 6. So hit Shift 6, you get the caret. And then our number of years is going to be our ending year minus our starting year. And our result here is Excel is displaying it in scientific notation, but again, if I want to get it in dollars and cents, I hit Control Shift and the number 4. Number 4 has a dollar sign above it, so that means that's why you hit it for reformatting in dollars and cents. We're going to need to make our column bigger in order to see the number, and there it is, 155 odd quadrillion dollars. So hopefully that made sense. Now let's return to the PowerPoint presentation.
Alright, still talking about compound interest, but moving on to compounding frequency. So we'll start with just another example. If you had $100 today and earned 10% again, but if the 10% is paid semi-annually, how much would you have in a year? And the key here is that when we talk about like semi-annual compounding, or if we say that 10% is paid semi-annually, it means you actually earn half of 10% every 6 months.
Okay.
So you don't get like 10% 6 months and then another 10% 6 months after that. You get half of the annual interest in 6 months, and then another half
And at the end of
another
the year, you
6
could have the
months.
same amount anyway.
Well, so you'd have virtually the same amount, but it's slightly different, and here's why. So if we just look at the first 6 months, this should look familiar. It's basically the same thing we did before when we were looking at annual interest,
Right.
except that we just, instead of 10%, we multiply by 5%, because that's half of interest. And then after another 6 months, we're going to take the 105 and multiply it by 5% again. And so this time, after 12 months, you end up with $110.25, whereas before you just had $110. And so the reason for that is that you earned some of your money earlier, and so in the second 6 months, you're earning interest on the interest you earned in the first 6 months. So it amounts to 25 cents over 6 months. You get a little bit extra money. So again, we can factor out the 105.
And again, this 105 it's the amount that we had after the first 6 months. So we can substitute in this equation from the top here, this equation, and that way we'll start with 100 instead of 105, which is the money we started with at the very beginning. And then again, we rewrite it as 5% plus 1 quantity squared. And then we're just going to rewrite it one more time. And the reason we basically want to look at it in terms of what's our annual interest rate, which was 10%, we said. And so the only thing that we're doing here is we're just taking this 5% and we're just writing it as 10 divided by 2. And this will make it a little bit more intuitive when we look at the general formula. So you basically have your interest rate divided by your compounding frequency. And then for the exponent, when you're compounding more than once a year, you have to factor that into the exponent by multiplying the number of years times the compounding frequency. So in this case, we were just looking at 1 year of interest. So it's just a 2 in the exponent here because 2 is the compounding frequency, and then the number of years is 1 so far. We're just looking at the first year, so it's 2 times 1 times equals 2, right? And then, so again, the general formula is P times 1 plus, and this time it's R over N, where N's the compounding frequency. And then it's raised to the N times T power, where T is, again, the number of years, N's compounding frequency. And that'll give you the future value at whatever year you stick in there.
Okay.
So, again, we'll look at an example. If you had $24 today, it's kind of the same example as last time, and you're earning 10%, but what if you're earning 10% semi-annually over that 382-year period? How much money would you have? And then, same thing, but what if it was quarterly interest, and what if it was monthly interest? And by the way, most savings account, do you have a savings account?
Yeah, checking.
Okay.
Yeah.
So you probably don't earn interest in your checking account, I'm guessing. Most savings accounts pay a little bit of interest, and they'll generally pay interest monthly. So every month you earn a little bit of interest. Just see. So the point of this is that, okay, we looked at that example of $100 compounded semi-annually, and you end up with 110.25, remember? It's like, okay, an extra 25 cents because you're compounding semi-annually, whatever.
Right.
It's not that big a deal, but over a long period of time, it makes a big difference. It's like $200 quadrillion different if you go from semi-annual to quarterly, and then it's like another $200 quadrillion to go from quarterly to monthly. So, again, the force of compound interest is pretty remarkable. I guess that's just the point of this. So let's go back over to Excel, and we'll basically make the same spreadsheet that we made before, but we'll have basically another input that allows you to adjust the compounding frequency as well as the start date, the end date, all those things. So again, we go to this website, weiner.andrew.j.googlepages.com/intro to finance, and now this time we're going to download Excel exercise number 2. And again, there are two tabs to this exercise. The first tab is year by year, very similar to Excel exercise number 1. The goal is going to be to list all the years from 1626 through 2008 and to figure out what the principal and interest is in each of those years. And then in the second tab, FV formula, the goal is going to be to write a formula in one single cell that calculates the future value based on these inputs. And we've just got one extra input this time, which is compounding frequency. And so once again, I'm going to go ahead and do this from scratch, but first, why don't you start with year by year? Why don't you just take a crack at completing the Excel exercise, and then you can play the video and watch me do it if you have any problems doing it on your own. So here we go. Much like last time, we're going to want a column titled year, one titled principal, and one titled interest. And we're also going to need an input for our interest rate, which is 10%. And this time we're also going to need an input for our compounding frequency. So for starters, let's use semi-annual compounding, so our compounding frequency is 2. Again, I'm going to color code my inputs as yellow. First year is 1626. My starting principal amount is $24. I'm going to list the years in the same way I did last time, just taking the prior year, adding 1, and then copying down. All the way to 2008. Now, the way I'm going to do my principal and interest is going to be slightly different than last time. What I'm going to do is, rather than making the principal equal to the prior year's principal plus the prior year's interest, I'm going to calculate each year's principal on its own, and then based on the difference between the two principals of adjacent years, that will give me the interest earned in that year. So, for example, in 1626, my principal is $24. So, in 1627, I want to take that $24 and use it to calculate what my principal will be 1 year later, and just using that formula from the PowerPoint presentation. So my principal in 1627 is going to be $24 times 1 plus the interest rate divided by the compounding frequency raised to the exponent of the compounding frequency. Now, the other thing I want to do is I want to freeze some of these cell references. So F3 and F2 here contain my interest rate and my compounding frequency. I want to freeze those cell references so that later when I go to copy this formula down into the subsequent rows, I'm going to want those formulas to continue referencing F2 and F3 rather than referencing F3 and F4, F4 and F5, etc. And so again, the way I do that is I put in a $sign in front of the thing that I want to freeze. So in this case, I want to freeze the row number 3. I want to freeze this row number 3 here, and this row number 2. And hit enter. So that gives me my principal in year 1627, which is $26.46. And now that I've got that formula, what I can do is I can copy it, and I can paste it all the way down to here. I have to make my column a little wider. And I see that in 2008 I would end up with $370 or 370 quadrillion some dollars. And now the way I'm going to calculate the interest is I'm just going to take the difference between the principal in 2 given years. So in year 1, my interest is equal to my principal in year 2 minus my principal in year 1, $2.46. And again, I can just copy this formula all the way down. Oops. Now I'm not going to copy it all the way down to 2008 because I won't have anything to subtract in 2009. So the farthest I can copy it down is to make this column wider. Farthest I can copy it down is to 2007, because if I try to copy it down one more cell, then I end up with a negative number because it's subtracting a blank cell. So get rid of that. This is how far I copy it down. So my interest in my final year is about $34.5 quadrillion. Again, I'll go ahead and center these numbers, make my spreadsheet look nice, and I will make my column headings bold and underlined, and my labels here bold and underlined. Now, one other thing that I'll show you here before I move on to the second tab is notice how when we scroll down, the column headings disappear. It would be nice if when we scroll down we could still somehow see the column headings so that we didn't confuse our principal and our interest. Now, what you can do if you want to keep these column headings visible is you can use the freeze panes option, which in the version of Excel you're using is probably under the window menu item. So there should be something up at the top here that says window. You click on window and then you go to freeze panes. And when you do this, you have to make sure that you're highlighting cell A6, because the freeze panes option will look at whatever cell you're highlighting and it'll freeze everything above it and everything to the left of it. Now in this case we have nothing to the left of it, so it only freezes what's above my cursor. And so at any rate, now that I've used the freeze panes option, rows 1 through 5 are frozen, so when I scroll down, rows 1 through 5 remain visible, even though I'm scrolling down into the hundreds of rows. Excel will continue to show rows 1 through 5. So that is nice. Now let's go on to the FV formula tab, future value formula. Very similar to the first exercise, I'm going to want a single cell that will calculate the future value of an investment based on the inputs of start date, end date, principal, interest rate, and one extra input this time, which is compounding frequency. And these are my inputs, so I'm going to make them yellow. And this is going to be my output here. So my start date, 16/26, my end date, 2008, my principal, $24, my interest rate, 10%, and my compounding frequency, starting again with semi-annual, we get, so our compounding frequency is 2 times per year. And my formula is just going to be my principal times 1 plus my interest rate divided by my compounding frequency raised to the exponent of my number of years times the compounding frequency. Now, order of operations says that the exponent operation comes before the multiplication operation. So I need one extra set of parentheses here to make sure that the exponent contains this entire expression. So anyways, I hit enter. Again, Excel expresses this very large number in scientific notation. So to get it in dollars and cents, I hit Control, Shift, and the number 4. And we get 370 some quadrillion dollars. And so Now when we want to answer the rest of the question, which says what if we're using quarterly compounding, it's very simple to just change that one input and it gives us the answer for quarterly compounding. And once again, when we want to know what about monthly compounding, what's the future value using monthly compounding, it's very easy to just change that input and get the answer. We can do the same thing on our first tab here. Change the compounding frequency to 4 for quarterly. All the formulas adjust. Change the compounding frequency to 12 for monthly. And all the formulas adjust. So that is all for class number 1. Hopefully it all made sense. Whenever you're ready, go ahead and open the video for class number 2.